Welcome to the Camunda BPM online training. Today we want to have a look at the BPMN in more depth and more BPMN elements. Let's get started with that one. First of all, just a quick history. What is the BPMN? The BPMN was developed originally by Steve White within the IBM, but pretty soon there was a BPMI.org created the Business Process Management Initiative to get it into a broader range, not only within the IBM, and to make it more vendor independent. 2005, I think that was the most important milestone. It was taken over from the object management group, the OMG. You might know them from the UML or stuff like this. And recently in 2013, it got even an ISO standard. So it's really a worldwide standard. It's adopted by all major vendors, by all the BPMS, by the universities are teaching BPMN, and it's pretty widespread there. The current version is BPMN 2.0.1. Basically, it's 2.0. The .1, the last minor version, was basically introduced with the ISO standard. There were a couple of formatization stuff, but not real content changes. There is no concrete plan for version 2.1 or 3.0, since all the vendors are still implementing it, so there's not a lot of time for improvement, but I expect something to happen maybe next year in that area. Yeah, if you want to learn BPMN, I think that's a pretty good literature. You can get the real life BPMN book. You get it in English or in German or in Spanish. It explains it from a non-technical view, so it's really you can learn BPMN from a business perspective. You can hand it over to your project manager, your business analyst, so it's really not technical. We will upload a PDF version of the book in the space for this training, so you can download a PDF version, but you can also order a printed version or a Kindle version. Okay, so let's have a look at the BPMN. This is a very easy process. It's actually about eating. All the processes in the book are about eating. So you normally start to get hungry pretty soon, but we switch that later on. So don't worry. So we have a very easy process. We have the events. In this case, it's a non-start event, so it's not a message or timer or something. It's just not specified. So it's a non-start event. Process instance starts here. Then we have the tasks. We have the sequence flows. We have end events with a thick line. Okay, in this case, it's a non-end event. And we might have intermediate events with the double lines here. That means some event occurs during the process flow. I think that's pretty obvious. That's a process model, the process definition in terms of Camunda BPM. And when we start one instance of that process, so I have hunger now, then we start a process instance. And this is basically, in the BPMN, you can imagine it like to have a token in the process, and that moves through the process model as you advance in the process. So in this case, we might start with hunger noticed, and then this moves through shop for groceries, prepare a meal, then the meal is prepared, then we eat it, and then we're done. When the token arrives in an end event, the process instance ends. I think pretty straightforward, but important to get that concept. I think you already got it in some of the earlier modules, because we already saw BPMN models, right? We already saw the XOR gateway. In this case, the XOR gateway is an exclusive gateway. So what we do is we look in some data, process variables, and then decide which of the outgoing sequence flows we take. It's only one, so it's an either or. So in this case, we choose what we want to eat, and then we either eat pasta or steak or salad. Okay, so the token basically moves out through one of the outgoing sequence flows. That's pretty clear. If not, you always have the possibility to ask in our online meetings. Feel free to ask, or the forum. So that's an XOR gateway. The XOR gateway can be used, I mean, that's normally pretty obvious, but that's not that obvious maybe. The XOR gateway can be used for merging as well. So you might, the token goes out via one of the sequence flows. And the merging one means there must be one token on one of the incoming sequence flows. It doesn't matter which one, only one contains a token, and then we move on. You might even combine the two. So from the specification, what the specification does, BPMN 2.0, it defines the so-called execution semantics. And there they describe how each element has to behave in an engine. And this behavior is defined as on each incoming sequence flow, if there is at least one token on one of the incoming sequence flows, and we advance through one of the outgoing sequence flows. And this is basically defined by a condition on the outgoing sequence flow, which one we take. We will see that when we do the live demo in 2 minutes. Okay, that's an XOR gateway. Still pretty straightforward, I think. The next gateway, which is pretty interesting and we did not yet tackle, is the parallel gateway. The parallel gateway means that in this case I have parallel flows. And that means when the token arrives here, a new token is generated on each of the outgoing sequence flows. In this case, it means I go the path for pasta or steak, and I do the prepare salad. Hope that's obvious. So I have one token here, one token here. That's the easy part. And then this happens in parallel. The joining one, the synchronizing one, that's interesting now because that behaves pretty different than this one. In this case, we say, okay, there might be a token here or here. We don't care if we get one token, we move on. This gateway means I wait for one token on each incoming sequence flow. So here we wait until we get a token from here and here. So we might have chosen pasta. So we might have chosen pasta. So we're still in the pasta making because that takes 15 minutes and we are going that way. So we are finished with the salad. That means this token has to wait because it says, okay, there is another sequence flow, but not yet a token. So we wait, we simply wait. When this token moves on and it arrives here, both tokens are there, so I can move on with the meal. Okay, pretty straightforward. Okay. What happens in that case? That's a pretty interesting thing. I'll let you think about for 10 seconds. Oh, we had that joke already, right? You can use the pause button to think a bit longer, but it's really interesting to think about it. So we make the same example. We cook the pasta and we prepare the salad. Now we're done with the salad. What happens? As this is not a parallel gateway, it's an XOR gateway. It's an exclusive gateway. It means if we have a token there, we move on. Then we start eating the meal for 20 minutes. So after 5 more minutes, the cooked pasta is ready. It arrives here. And we don't care how many tokens we have. If this one arrives here, it moves on. So that basically means we start the eat meal activity twice. Okay, this is not synchronized. It's basically some participants compare that to it's not like a really good restaurant, it's more like McDonald's or whatever. So as soon there's something finished, you get it, and then you start eating, and then you get the next dish and these kind of things. So it's not really synchronized. It might be what you want, but most of the time it's not. Okay, because this is normally it's an error in the modeling, so it's important to see the difference, right, with the parallel and without. That's another example where you see, okay, in this case, it's obviously an error. What happens here? Yeah. So you enter the card, you say how many money you want to have, then the money is prepared, your account is charged, and you get the money twice because this path moved on and this path moved on as well. So you get the money twice. Okay, so this is obviously not what you want to have. After some practice with BPMN, you recognize these situations even in big models immediately. It's a bit of training, but it's good to have a look at these situations. If this was really intended, what I would do, I would add even a comment maybe to to document that this was really intended, because it's something everybody will look at and say, okay, well, that's a bit strange here. Okay, that's a parallel gateway. There is one more gateway we want to have a quick look at, and then we do a demo. Let's imagine we want to have basically all options. Okay, so really all options. Currently, it means I parallelize here, so I can have salad and the main dish, but I can skip the salad. I can skip the main dish, okay, or I can make pasta or steak. I can even make nothing, actually. That works here. And this is a bit, yeah, maybe not the nicest process, right? Because it's a bit hard to grasp. And in these cases, you can use another gateway, which is the so-called OR gateway, the inclusive gateway. The inclusive gateway is defined as you basically produce one token on one or more outgoing sequence flows. Okay, in this case, it means if I decide for something real, I go that way. If I decide for salad, I go that way. And maybe I've decided for something real and salad, so I go both ways. That works here. That's for the splitting part. For the merging part, it's actually pretty interesting, because that basically, what do you think does it mean here? Obviously, it has somehow to match the first gateway. And that's what a lot of people intuitively think. They are somehow connected, the two. But that's not true, actually. The merging OR gateway basically says I move on the token if at least one token arrives and no other token can arrive anymore, which is up somewhere the process flow. In this case, it basically corresponds to the first one. So let's say I have only something real. So I move on, pasta, I'm ready with the pasta, I'm moving on, I'm arriving here. And then this one checks, okay, I have a token and I have another incoming sequence flow. So it basically checks, oh, but there is no token. It's not possible that I get any token later on, so I can move on. If I have the other token as well, and I'm still in the prepare salad, let's assume that takes longer this time, then the gateway would wait for that token. Okay, that's actually a bit tricky. Not only for the process engine, it's hard for the process engine to recognize when it should move on or not, but it's also hard for people reading the BPMN, because it's always hard to get what happens here. So the OR gateway, you always, yeah, don't overuse it. Okay, if you have a really good use case for it, it's fine, but it's better to stick to the OR and the AND gateways. And you have to wait a second. You have to be aware that not all situations are easy with the OR gateway. So let's assume that one, right? So I go this way, and let's assume I go both paths. So I'm in the task 2, I'm in the task 1. Now my task 1 moves on. I arrive here. Now I have to wait, actually, because it might be that there is another token coming from here. But as soon as I move on here, and let's say I take this turn, as soon as I move out the gateway through that path, I have to recognize here, oh, no, it's not possible anymore that I get a token from here, so I have to move on as well. And that's pretty hard. I mean, for the human and for the process engine. And this is actually something not executable at the moment in Camunda BPM. So you might make a small test case if you have these situations, if it's executable or not. So we don't have 100% every possibility is possible in Camunda BPM. Important to know, but we always recommend to avoid these situations anyway, because these are not really good process models. They are not really easily readable. Okay, that is an important thing. Yeah, if you look at that process model, a quick question: what is the difference between this one? I have an OR gateway and the pasta and the steak, or I make it even more compact, and have only one gateway for these two guys. What do you think? What's the difference? Or is it just better? I hope you recognize actually, because this is different from the semantics. It's different because now I can eat pasta, steak, and salad. Maybe that's cool for you, but it's something different than I modeled here. Okay, important to know. Okay, maybe enough theory for now. Let's switch to Eclipse. Let's do something live. Let's have a look at that. I prepared a small process, which is actually yeah, a pretty easy one. So we have the user task. When we decide for A or B, then we can see how this gateway is working. We have another user task here. We have a parallel gateway and joining one, and then that's it. Okay, hopefully an easy one. How do I do the decision? That's what I mentioned earlier. You have to provide some data. So what I do in the user task, I have very easy form here where I write a process variable decision. It might be B or C. Okay, so it might be B. And there we use expression language. So the Java Unified Expression Language, where we have the decision. That's the string we have from the form. And this should contain B. I come back to that in a minute why I used contains and not just equals. And the other one is the other way around. So I have the decision contains C. Okay, hopefully pretty easy. So let's have a look at that. I build it using my Maven and I deploy it to my JBoss. I'm actually using, I could do a unit test as well, but I think it's a bit nicer to have it graphically using task list and cockpit and all these things because it's a bit more visual. Okay, I'll make it. So I go to the task list. I start a new demo gateway process. Okay. What happened, I think, is pretty obvious. So I have the user task, and now I decide for B or C. And this is now the form I provided. So I can select B or C. Let's do the boring part first. So we do the B path. So we obviously walk that way. Okay, that makes sense. We stop that one. We do the next one. And now we go the C path. So we go the other way. Right? Okay, makes sense. There's one thing you can have a look at that's interesting as well. So if I start the next one, I made an option invalid. Okay, so my decision variable has the value invalid. So neither of the two decisions really fit. Okay, so neither this nor that will evaluate to true. What do you think that happens here? It's for us it's a runtime exception. From here, I cannot submit task. No outgoing sequence flow of the exclusive gateway 1. Again, the hint, it would be good to have readable IDs for that stuff. Could be selected for continuing the process. So it's really a runtime exception, and that is what the BPMN defines as well. So we have no idea how to move on, so we cannot move on. Okay. Yeah, we don't care about that one. So that's C. Now we move on here from user task C, and we have the parallel gateway. There's one thing really important about the parallel gateway. I mean, it's pretty obvious what we do. We walk D and E, and we do F and G, both in parallel. So we will end up with two tasks in the task list, user task E and user task G. But the important thing is parallel is not in the terms of threading. So it's not parallel threads or something like that. The engine itself will basically walk through the first wave first until it reaches a wait state. Okay, then it basically goes back in the call stack and basically walk the other way until it reaches the wait state. That's really important. Okay, so it's not multiple threads what you get here. It's still single threaded, but it's parallel in terms of business modeling. So you have the user tasks in parallel. Both of them are on the task list, and you can do either E first or D first, or it actually doesn't matter. That's important to grasp. In order to show that, to prove that, what I did is I inserted a service task. And this service task is implemented by a small Java delegate that basically prints out what it does and then sleeps for 5 seconds and then goes on. And this makes it now easily possible. Okay, that was the stack trace from the bad decision we did. We can see that. So I complete the task. Okay, this one will even block because it's not asynchronous. We're starting the service task D, that finished. Then we're starting the service task F. Okay, that's finished. Now we get back the thread. So our task list is responding again, and we have E and G in parallel. Okay, really important to get that. Okay, let me show you one thing more on that process model. I want to change the XOR gateway to an OR gateway, and that's actually why I did the contains here. Because now what I can do in the select box, maybe you saw it, I have a multiple select box, so I can select multiple values, and then this will get a string comma separated list. That case was easy to build actually for the example. So that's I can easily do OR gateway here. So let's quickly deploy that. Should work. Okay, that deployed. So we start a new one. User A. So we have the OR gateway, and now I can select B and C, completed, and what I get is B and C. With the OR gateway, I could still select just one. That works as well. So only B. Then we have only B. Pretty easy, actually. You just have to know your gateways. One last thing here. With the XOR gateway, there is something sometimes handy as well. You can select default flow. Now I should really name that sequence flow C. So I can select the default flow. Then you get this small line here. So that means if none of the other conditions match, I use that one. Okay, it's some kind of else in an if-else statement. So you have the switch case, and the else part. Okay. Then I don't need the condition actually here. The important thing is you should use that only if you have these default cases. So if you say approved yes or no, I would not use the default flow for the no path or something like that. It's not the one that you go most or whatever. It's basically really about having some else path. Okay, so that works as well. When you evaluate the conditions, if you have multiple outgoing sequence flows, it basically uses the order in the XML. So it's not really easy to see here which one are evaluated in which order. But best don't assume any order. The best is you have conditions which are really exclusive. Okay. So that we can see that in a minute. Now I could use invalid as well to walk here. And I want to show you something more here. So that's interesting as well. We haven't yet talked about when a process instance ends. And this is interesting as well. So if I do the process like that, maybe we remove that time-consuming stuff. because we don't need that anymore. And we save some time here. So that's our parallel gateway. Just make it nice quickly. Okay, so we task ENG. The important thing is a process instance now ends when all the multiple tokens here are ended, not earlier, right? So let's start that. Demo gateway started. I use invalid because I now have the default flow. Okay, so I'm in C. I use that. Now I have ENG. What I do in parallel is I open cockpit for that process instance. So we use that one. Okay, so we have it in ENG. Now if I, for example, complete G, what happens is that I still have the process instance because I'm still in E. Now I switch to the history actually, because if I complete E, now the process instance is completed. Okay, so it's really ended. Important concept. There's one last thing I want to have a look at. There's a so-called termination end event, which is sometimes handy, sometimes. What it basically does, it means when I have done E, I end the whole process instance, or better, the current scope. Okay, in this case, it's the whole process instance. So I basically cancel the other one in this case. Okay, we quickly can have a look at that as well. So I redeploy it. I'm already pretty quick in clicking through it. So we do the gateway, we start it, we do C, we basically complete it. Now we have G and E. Okay, so we have a look at that. We have a new version. So it's E and G. So I continue with E, the one with the terminate. I complete it. And G is gone as well. I go to the history. What you can see, it's basically this one has ended, and the orange one means this one was cancelled by. Okay. Hopefully straightforward as well. So we already learned quite a lot actually about all the gateways, the parallel gateway, the OR gateway, the XOR gateway, about parallel paths of execution, which are not parallel in terms of threading, but in terms of the business process. And you learned about the when a process instance ends, basically when all the tokens in a process instance end, or if you use, for example, the terminator end event. It's already pretty good what we have. But we have a bit more in the BPMN for today. Okay, so this is what we had a look like. That's actually what we checked as well. Okay, when all tokens are ended. Yeah, we already saw errors in the error management module. Errors are terminating as well. So if I use an error end event here instead of a terminate end event, that would terminate the process instance as well. Okay. Now we want to have a quick look at sub-processes. Sub-processes, there are basically two types of sub-processes in BPMN. The first is the so-called embedded sub-process, and the second one is the so-called call activity. The first is what we have here. It's basically like a scope in your process model. The interesting thing is if you have a look at it in the XML. Okay, so we see the process, and then we have the sub-process, and in that sub-process we have all the elements. So it's basically really embedded. Okay, it's not a separate file, it's not a separate process, it's the same process definition, the same process instance running here. It's just a scope. And this scope can be used, for example, to attach boundary events. And in this case, it will mean it doesn't matter if you're taking too long and check order items or prepare order items. If the whole sub-process takes too long, I'm going out over that sequence flow. It might be interesting sometimes with message boundary events as well, that you say you have one phase in the process and there you can cancel it. And a later phase there you cannot easily cancel it or something like that. Okay, so the scope is often used for boundary events. It's sometimes used for data scopes as well, or for error management. But Keep that in mind. So that's really an embedded subprocess. It's not reusable. Okay, it's really embedded. You use it there where you draw it. It might be possible that your tool can collapse it, so it's shown like this one with a small plus, but it's actually not really common. The Camunda BPM, the modeler, is able to collapse and collapse it, but it's actually not really nice, because then you still have a lot of space around it, and that's not easy to remove. So there are not a lot of use cases where we really use that collapsing stuff. Okay, that's the embedded. The other thing is the call activity. And the important thing here is to recognize the difference with the thick border. The thick border is the important thing. Okay, this means the call activity really references a process which is defined somewhere else. Okay, so the shipment might be, or is, a completely different process defined in an own XML file, deployed as a separate process definition. And this is just referenced and started when you walk into the call activity. And then the main process here waits until the call process is finished, and then it's moving on. Okay? Pretty straightforward here, but important to get the difference. Embedded subprocess, call activity. And if you look at the call activity in the XML, obviously the process is not embedded. Oh, I don't have the XML here. Yeah, we will have a look at that in a minute. But we reference the process we want to call, and we basically use the key for that. And I better want to have a look at that in the demo in a minute. Okay, so we come back to that. One thing which is really interesting, especially together with subprocesses, but not tied to it, is something called multiple instance. Multiple instance is really cool. And what it does parallel processing as well, like the parallel gateway. But what you do, you hand in a list of items, and then it's done for every item of the list in parallel. Okay, this one is parallel. You might want to do it sequentially, one after the other as well. But the important thing is that's like a for each. Okay, so you get in with a list, and then you do it for every item in parallel. And then, that's what I said earlier, you have an own variable scope for that subprocess. So in this case, the item might be a process variable, a local variable for the scope, so it has a different value for each of the instances running here. Okay, let's have a look at that with a quick demo. So what I do, I create a new process model. I want to do that from scratch, actually. So I call it multiple instance. So we basically do what we saw. So I create a so-called subprocess. Well, let's do it like that. Maybe we get some space, and we say afterwards, where is it? The call activity might be the shipment we have. Right. Let's have a look at that in a minute. And then we have the end event. So far, so good. Within there, we have two user tasks. Okay. So this one was check order item, and this is something actually pretty handy. I now use expression language here as well. So it's evaluated when the name is written into the task in the database. So this is queried later on and shown in the task list. Check order item and prepare. Let's do it like that. Prepare order item. Okay. This one should be multiple instance. So what I do here, I check its multiple instance. I could say it sequentially, but I like the parallel one actually. I configure which variable holds the list or the collection of items, so that are my order items. and in which variable they should be written. I call that item. Actually, that's it. So I configure this one. Now what I have to do, I actually have to provide order items. And since I want to use the default task list, it's not easily possible to hand in lists there. So what I do is a quick trick. I created a execution listener. We have tackled that. So a listener is something I can attach to various events in the process. So for example, when a process instance starts, I can execute a listener. When a transition is taken, when an activity is entered or exited, then you can add some execution listener. So what I can do, I add that here. So I say, if I want to execute that listener, if I have the end event of the start event. So if I'm actually moving out of the start event. And this one creates an order items list of apples and oranges and creates an order ID. We use that later. Don't care about that. Okay, so that should already work. Now I have the shipment process. The shipment process is a call activity. So here I really have to reference another process. I prepared one, actually, the shipment process. This one is the key of it. So what I basically do here is I reference that. Called element is the key of the other process. And now I can configure a couple of things. I can configure the version which should be used. Latest is really the most current version deployed in the process engine. That's the default. Deployment means that it should be in the same version as the multiple instance process if it's part of the same board. So what we do there, we basically always make a bundle of one version and tie them together. That has a lot of advantages in terms of operations. If you use latest, actually, you can have, if you're using a lot of call activities, you can have really strange mixtures of different versions, making it hard to understand what happens. So that's why we prefer deployment normally, or you can say version to specify version 1 or 2 or whatever. Okay, I use latest for the moment. Then we can define which process variables we want to pass in the process. So I could basically specify pass all variables, so they are copied into it. That's important. It's a copy. It's a call by value. Or it can specify which variables I want to copy. And in this case, I want to copy the order ID. I could use the expression language as well. And I want to copy it in the in the process variable reference ID, because the shipment might not know about the order because they are shipping orders or return items or whatever, but they want a reference, for example. Okay. If you wonder why I don't have the shipment string here, that's actually a bug of my current modeler here, so we have to reopen it. So my process model looks fine. I have to give him BPMN demo multiple instance and ID. Make it executable, that's important. So that actually should already work. Let's try that. I deployed. There's my demos, looks fine. I'm going to the task list, starting multiple instance. I haven't defined any forms, so I use the generic ones. Yep, something I forgot actually. Pretty good example, because I don't see anything in the task list, but it was started. So I have one process instance, okay, 2 items here, currently here. Now I'm in the process instance. I see I have 2 tokens currently here. I see my order items list, so that worked. You can have a look at it in Cockpit as well. So we do a JSON transformation. I could change it here. I generated an order ID, and I have the item apples and the item oranges. And if you have good eyes and look on the ID of the sub-process, you will recognize that this one is different. Okay, so I have it for the apples here, and the oranges here. Okay, we don't see that graphically actually because it's still the same activity. But what I forgot actually, if I look at the user task, I forgot to assign it to somebody. So I will do that now. I assign them to demo via the cockpit. Okay, and then I will see them in the task list as well. So I see two things, apples and oranges. Okay. Let's quickly add the assignee here. I forget. Okay. If I would do something like adding a boundary event here and say this is a timer, what I said earlier, it doesn't matter where I am. It really cancels everything here. Okay, so I can say handle timeout. I'm done. And it might take like 30 seconds. Duration, period time, 30 seconds. Okay, and it really cancels the whole thing here according to that as well. So let's check that. I have forgotten to do the assignment again, right? Okay, let's do it another time. In the meanwhile, I do that user task here. Okay, so I did that one. If I have a look at it now, I basically have two running instances of subprocess. One is here, one is here. That one as well. Now what I have to do, I have to actually change the assignee here as well. Bit of a pity to forget it actually, but no problem. And I complete them. I complete this one. And now I'm in the do shipment. Okay, that's interesting. So let's check it here. I'm in the shipment. I can see the process instances I called in Cockpit, so I can basically follow them. And there I move to a completely different process instance. If you look at the variables, they are completely different. Just the one I handed over, the reference ID is set. Okay. Fine. That was that. Now we can check the timer. Actually, maybe the timer is not that important to check. I hope you believe that the timer is working. One thing I wanted to show you here quickly is the adding a message event. We, or you hopefully remember that from an earlier lab about the client API. I have to say this subprocess is now triggered by event. Then I have the start event. I say this is a message event because this is a pretty common use case where you say, okay, I might have something like cancellation received. So somebody wants to cancel the message. I already created a message, no? So it might be a message cancel order. And in this case, I might want to do some stuff, and I'm done. And the installation, and this is the demo user. And the important thing is here, this one really interrupts the whole stuff which is going on here. Okay, let's quickly check that. In order to check that, I have to hand in the message here. So this cannot be done via the normal task list. So what I did, I created a quick web service actually to do that. Just have to adjust the message name. So it's a web service. I get my process engine, the runtime service. I create a message correlation for that message. And now I correlate with the business variable with the order ID. And that sometimes makes sense. If we can decide, we normally try to use a UUID to correlate because that's the business variable which might change or where you might have duplicates or these kind of things. So that makes it a bit more complicated. But as you can see, it's pretty easy actually to do. So I redeploy that thing. And it's actually quite common because what we provide is the API to hand in the message and to do the correlation. But providing, for example, JMS or web service infrastructure, that's something up to you. That's something we don't provide. We provide the Java and the REST API for it. But as you can see, it's really easy. And it's basically the same for JMS implementation. It's really straightforward. Okay, so we should have a web service. I start a new process. Where is my task list? Okay, we start process instance, start it. Now I go to cockpit. What I can see, okay, there's one running. I will check the order ID. I go to my SOAP UI. Let's do a new request here for the web service. I hand in the order ID. Okay, that worked. So if I have a look at that one now, what I did, I basically jumped in the handler correlation path. Okay, so I canceled the whole one and I interrupted that and I walked this way. We can see the, maybe in the background, I start the next one, so we see the timeout as well. There's one thing interesting here to see for that event subprocess. What we can do is we can make the event non-interrupting, so it gets that dashed line. Okay, it's maybe not for cancellation. It's not not that the example is not that good, so it might be like information requested handle request. Because cancellation, it's interrupting. I think that makes sense. But in this case, it's just something additional. And it's just that small checkbox you have to set. So it's not interrupting. Okay, so deploy that one. We move to cockpit. If we look at that one, so we see the one we had with the message, and we see the timeout as well. So that worked as well. Pretty cool. Go to the task list. Start another one. So we have a new version, right? We have one instance. We check the order ID. We go to our web service, hand in that one. That worked. And we can see what happens now. We're still in there, and we're here. Okay, and if we wait for the 30 seconds, we are here and here. So it doesn't disturb the other things which are going on. Pretty important to know the difference. And that's actually really powerful because it can combine a lot of the things. It could be a message event, an error event, error must be interrupting, but anyway, and a lot of combinations which are possible there. Okay, I prepared one last thing I want to show you, because that's not obvious as well. We talked about the terminate event earlier. So what do you think if I maybe do something like check order item, approve no, and then I use the terminate event? What do you think that happens? I maybe for a matter of timing, I want to skip trying that. But I can prove you, if you want to play around with it later on, you can check that this one terminates only the current scope. Okay, so this one, it basically means only the current instance. If I have apples and oranges and I do not approve apples, the apples are terminated, but the oranges will go through, and then I will move on through that outgoing sequence flow. Important to know. There's one thing how you can cancel a whole multiple instance subprocess. It's already pretty advanced stuff, to be honest, but I want to give you an impression on how the BPMN thinks and how that works. What you could do is you could throw an arrow. So you say, okay, this is an error. If something that cannot be approved, it's really an error. And then I have to catch the error, because if you remember the error management module, if you do not handle an error, it simply ended the token here. And that means it's ended and the other one continues. So what we really have to do is we have to catch the error. So we want to make this triggered by event. Okay. then we can say this is an error event, and we maybe simply end. Why not? And we have to add an error. Yeah, order not approved. This one looks perfect. So we take that one for both of them. This is the connection between them. And now it behaves differently. Wait a second, we have to make that one executable. And because it has the same ID as the one I built earlier, which is not valid, I cannot have two different XML files for the same process. I make that not executable. So this one is now ignored by the engine, but this one should be deployed instead. So I deploy that one. Go to my task list. Let's check that. Start a new one. Start it. Now I have the checking. And we see that's the new instance, right? I actually have the B or C. I reused it, actually, misused it a bit. And I go this path. Good example of a bad user interface. I go this path if I decide for C. So if I do that, let's go to cockpit first. I go to the latest version. I see my instance. The instance is currently here. If I go to C and complete it, what I can do, I go to the history. No, I even don't need that. So I walk this way. Okay, this one canceled the whole multiple instance one. The other token was still in the user task, and I moved on via that via that error event and ended. Okay, so this one really terminated the multiple instances. Okay, pretty advanced stuff already. Don't worry if you didn't get all of the things. I hope the basic ideas got clear. So you have the sub-processes, you have the call activities, you have event sub-processes. Okay. You have multiple instances, and you have a lot of events and gateways. You're already pretty good. And we're almost finished with that module. So you saw the demo. I already mentioned what I did with the web service, like correlating the stuff is pretty common what we do. So a really common pattern is like sending an asynchronous message via JMS, for example, and later on getting a JMS message back, and therefore you create a message-driven bean, picking that up, and then calling our correlate message method you saw in the code. Pretty straightforward. The correlation is normally done either by process instance IDs. You hand over the process instance ID you have to the other system, which returns it back. It's actually not that good idea, actually, because you expose a lot of the internals of the process engine. So the external system should not know about the process instance ID. But you can do it, but I actually would not recommend it. You can use a business key or a process variable like a UUID. That's actually the best way for that single conversation. You create one unique UUID. So you create it when you send it, and then you can correlate with it. If you have to resend it, whysoever, you create a new UUID, and you see that you will get duplicate messages and these kind of things. So UUIDs are really cool here, if it's possible, if you can hand over a UUID to the other system. Very often that's not possible, and then you use some business motivated data like the order ID. Possible as well. If you have it on a token level, we haven't actually looked at that, but if you have it, the message receiving not here, but within this multiple instance, something like this, then you have to correlate the message not to the whole process instance, but to the right instance of the waiting task. That's possible as well with the same method, but you have to do the correlation right. So either on process variables which are local, or on the execution ID, so the token ID of the right path. Or you might have some various other mechanisms you might think of. Okay, doing that. So if you remember the arrow event, I hope you remember it. We did it in the arrow management stuff. Hopefully you remember the timer events. We didn't yet tackle that in a specific module, but I had it quite often on the way. And you now should be able to understand actually the boundary event, the interrupting one. So we interrupt that if the timer happens. Or the non-interrupting one, which basically means I do that in parallel. So what we pretty often have is like a two-step escalation. The first one just reminds, maybe every day. And the other one, after 2 weeks, I really do an escalation. Events can also be starting, like I can say every day or every 2 weeks, I create a new instance of the process automatically. That works in the engine as well. So what we have actually is a combination of different types of events and how you can use them. So what you already saw is the start events, you saw the interrupting boundaries, the non-interrupting boundary events. We saw actually the event subprocess, the non-interrupting event subprocess. That's actually pretty straightforward. The starting and the ending stuff. And the intermediates, which are basically just modeled in the flow. So I could say after I did that, I wanna wait for a message, for example. That's an intermediate message event, and that basically is a wait state again. Okay. And this is the table of the events which are possible in BPMN. It's actually taken from the user guide. So go to the docs, go to the BPMN reference, and there you will see exactly this table. You move down a bit, you see exactly the table, and you have links how you can use that. And again, the orange ones are the ones we are currently able to execute, so the engine is capable of them. And the not orange one, the gray ones, are not yet implemented. Okay, so you see we already have a lot of them. It's pretty cool. We don't have the conditional event, which basically means any condition could be true, like the weather is good. So that's a bit tricky actually for the engine to know. So what we normally do is we exchange that by a message, because we somehow get that the weather is good as an information outside of the engine, and then we send a message to the engine, the weather is good. Yeah, the link is actually just for drawing, so you can basically jump to another point in the diagram, just to remove the need to draw a long sequence flow. Not that important actually. You can have a look at the examples there. The signal we will tackle later in an advanced training about signals, errors we got. Escalation, it's basically not it's basically pretty comparable to an error, but with the difference that it's not really an interrupting error. The error says, okay, I cannot, I don't have the goods on stock and I cannot order them, so I cannot deliver the order for the customer. It's an error. The escalation could be something like, oh, we get the goods, but it takes like 2 days longer. You might want to send the customer an information about that. So I escalate that, but I don't interrupt. We don't have the escalation event yet in the engine. What we normally do if we need it, we exchange that by sending ourselves a message. We have the termination. And the compensation and the cancel events we will have a look at in the advanced training as well. So not for now. And you can have multiple events in one symbol, actually not really interesting at the moment. And you can specify multiple events for starting a new process instance. These are a bit esoteric and not that important in real life projects. So what I think we will do in future is the escalation, but yeah, on the other hand, we are already pretty complete. It's pretty good. Okay, these are the events. If you have questions about the BPMN coverage overall, have a look at the documentation I just showed you. So there you can see what we can do and what we cannot do. We are still working on the coverage, especially for the couple of the events which are missing, but we're already pretty close. Keep in mind that some of the elements we will not implement. The best example is always the undefined task. We cannot implement that in an engine. If you want to have a process executed by the engine, we have to know what it is. Undefined is not possible. Okay. And there's no vendor implementing 100% of BPMN. I think that's normal for standard. But we're pretty close already, and it's a pretty good standard actually. Yeah, there's more for BPMN to have a look at, which we will not tackle in this module. First of all, which is really interesting, if you might want to use different tools for modeling BPMN, that's fine with us. Actually, what we need is a valid BPMN 2.0 XML, maybe with the extensions we need. But you can use whatever tool you want if it is capable of modeling BPMN2 correctly, exporting it as BPMN 2.0 XML, and hopefully importing it again so you can do some kind of round trip. If you're interested, actually that's something, wait a second, how can I click on that? No. Weak tools, intro tools. So there's this website from the Model Interchange Working Group of the OMG, where my colleague Falco is engaged with. So I think he did quite a lot of the tables here. There you can have a look at the various tools, and if they're capable of BPMN, if they import it, if they export it, if they can do a round trip, and what issues they have. So how good actually it really works or not. And then you can, for example, check, sorry, I don't want to link the tool, but you can check how that looked like. So should actually get a picture. Maybe we use the Adonis. It's pretty common in Germany, but I still have a problem here. Because what you should see, actually, check it yourself, is on the left side you see the reference model as a picture, and on the right side you see what happened when you imported it in the tool. So you can get an idea how sophisticated that is at the moment. So that's pretty interesting to check, to keep an eye on. And this currently got a lot of attention, and that improves pressure on the vendors to really do BPMN. So that's really cool. We made a lot of progress over the last 2 years. So if you want to use a different BPMN modeler, that might be fine. Especially if you have one for the business analysts already settled. If they already use something, it might be a good idea to get into an approach where they can keep their tool, and we on the technical level basically just add the technical information, get it running, and then do the round trip back to their tool. We have a lot of things around that, like we have an own tool which is called Cycle, which can do the round trip. There's a lot about using the BPMN, especially collaborations. We didn't tackle that yet, for really doing a business IT alignment. And this is something we will do in the advanced training. We describe it in the book and in the tutorial, so have a look if you're interested. There's a lot of cool stuff in there as well, but not for today. For today, we're basically done. I hope that was kind of fun. I think it's always fun to use BPMN. Please have a look at the examples, play with them, play with your own elements, your own BPMN processes. If you're in doubt how that behaves, write a test. I mean, you don't have a click through it with the task list like I did today, because I think it's more visual, but you can write unit tests, okay? You have the client API and unit test module, so have a look at that. If you're unsure how to write unit tests, and then write unit tests for it. Enjoy it. See you next time. Thank you.